Today we're going to talk about the introduction of how to program a mobile device like a UAV using microprocessor and microcontrollers. So let's talk about the goals of this course first. In this course, we're going to learn about microprocessors and microcontrollers. Before we do that, we're going to prepare you guys to learn basic programming skills using C language, and we are going to learn how to apply microcontroller units in engineering applications as well. And in addition to that, we're going to learn the basic programming skills and techniques of circuit verification. So in other words, we are not only learning the programming itself, we're going to learn a little bit about how to build the basic circuits so that we can use microprocessor unit to communicate with those devices and complete the task we are assigned for in engineering applications. And also, we're going to learn basics of embedded systems, because nowadays we're not just programming a microprocessor or using desktop. We need to include a very small computer system in our engineering applications, and that is something we call embedded systems. Let's talk about microprocessor and the microcontroller. When we are dealing with microprocessor or microcontrollers in the control application, we are talking about we size down a big computer system into a very small size one. And in those kind of microcontroller unit, usually you're going to see just a board that is going to include a CPU or a processor that is going to be integrating with memory, storage, and programmable input-output ports. So we can use this specific board to get the information from external device by getting the input signals, and we can also send out the signals to, let's say, motors or solenoids, so that the external environment can actually be controlled by those kind of microprocessor or microcontrollers. Nowadays, microcontrollers is very popular, and we can see it's everywhere, like the HVAC system, the HVAC controller you have in your wall in your house, those kind of things. And we can see a lot of different kind of power tools, toys, and very broad applications we use on a daily basis. We are using embedded systems to be included in those kind of devices, and in many different kind of applications, from kids toys to a big unit machines. And what is the difference between the microprocessor and the microcontroller? They are similar but not identical. A microprocessor is actually a bigger name for microcontrollers. Microcontrollers is a microprocessor with additional functions in the chip. For instance, if we are dealing with microprocessor, normally we're talking about digital input and output. So every time we want to communicate with external environment, we are using digital information, such as we have 8-bit, 16-bit, or a digital image to communicate with other microprocessors. But when we are talking about microcontrollers, normally we are also controlling or communicating with analog environment. For instance, if you have 5 volts or 2.4 volts or 2.3123 volts, those kind of different numbers, which is not just 0 and 1. We are using microcontrollers because microcontrollers normally is slower, but it is designed to deal with those kind of analog environment, so that when we have a light bulb, we want it to change its brightness. We are not just sending out 0 and 1, which means on or off. We are actually can control the bulb to be dimmed to a certain level, or to turn the bulb to its full brightness, those kind of stuff. So those kind of things is the difference between the microprocessor, which is digital information only, and the microcontroller, which can deal with analog information. So microprocessors all when we are dealing with those kind of things, it has a very different things between microcontroller and desktop we use on a daily basis. Because when we are using microcontrollers, normally we want to have the program to be executed all by itself, which means when we turn on the power, the microcontroller is going to execute a certain firmware or program installed or has been programmed in the storage itself. Not like when we are using desktop, we have Windows, we have Linux, we have Mac OS. So those kind of things can allow you to run multiple programs all by yourself. And when you start, it is running operating system, and you need to interact with the operating system before it can start to do something you want it to do. But microcontroller is only executing something has been programmed into it, and it's kind of like a single program dealing with the specific application you assign it to do. So that's a very basic difference between a desktop processor and the application of microcontroller. So what is the basic architectures of a computer? Since its invention of a computer, it doesn't change too much in the past decades. So when we have those kind of things, normally we include a CPU. The CPU is going to include a control unit, and we also have some kind of logic unit that is going to deal with those kind of operation. So when we include those two things together, we call it CPU. And of course, when we have CPU, we need to store some data. It may be a measurement of external environment, or it's a recording of some operational results. So we put that into memory first. However, when we have memory, it's kind of like short term. Every time you turn over the power, data stored in the memory is going to lost, or it's going to disappear. So in order to keep everything into some place that we can look it up later when we have time, we need to use external storage, or we use in your computer we use hard drive. In the we use hard drive. If we are using microprocessor, we are using ROM. Nowadays, you can use flash drive. That include SD card, USB drive, those kind of stuff to serve as your storage unit. But normally, we are using flash memory to store those kind of things, which means if we want to erase the data in the storage, you can do that. But if we turn off the power, the data remains the same unless we ask the ROM to erase itself. And in addition to that, we have some input devices such as mouse, keyboard in your desktop. But if we are talking about microprocessor, normally we're talking about switch or sensor. Those two things are something we're going to learn in this class. And of course, if we have a computer, that is usually need to interact with people or external environment. So if this is a computer, normally we are going to have a monitor so that you know what's going on in the system. But if we are dealing with a microprocessor, typically we're going to have some kind of like a motor or actuator, so that we know how to control the external environment. So nowadays we are using embedded system, which is something I talked about earlier. An embedded system usually means a computer system that is designed for specific control tasks. Keep in mind, when we are talking about embedded system, normally we are dealing with control applications, and in most of the cases we also call those kind of things mechatronic systems. So such kind of systems is embedded as part of the complete device. So for instance, we can call let's say Amazon Echo Dot. It is an embedded system because it includes one of a small computer in the system, and also we have a speaker in the system. So the speaker has some communication capability using Bluetooth, but overall the microprocessor unit or the small computer unit in Amazon Echo Dot is actually the computer part, and that is embedded within the overall system. That is something we call embedded system nowadays. But in the more broad applications, normally we are going to include some kind of electronic hardware and mechanical components. With the computing power adopted, the computing power of the adopted microcontroller and embedded system usually can deal with real-time computing capabilities. But sometimes a microprocessor is not good enough. We also using some kind of a digital signal processors or something we call DSP. Normally this kind of things can be as high as maybe 500 megahertz. When the controller is dealing with maybe 220k hertz or just like 1 megahertz, a DSP can be a much faster device and can do much more things than a microprocessor can do. Keep in mind, when we are talking about microcontroller unit, normally we're talking about a unit that is only $20 or $5 or even 50 cents. We are not talking about Intel i7 Core i7 or AMD, those kind of powerful computer processors. We are talking about something which is cheap. And when we are using embedded systems, normally we mean we're going to use millions of those kind of things on the market. So if you have an HVAC system, we want to use a very simple controller or microcontroller in the system. Normally we hope the microcontroller is just doing its job. We don't need to have a very powerful processor to be included in the device. So normally we can say, okay, a $2 or $10 microprocessor will be good enough. So that's the difference between the desktop processor and the microcontrollers we use in embedded systems. So who actually do microcontroller? So we might know that if we are talking about the processor used for our desktop, we are talking about IBM, Intel, or AMD. But when we are talking about microcontroller, it's a little bit different because we're talking about low cost and fast response time, and we also talk about the experience of control applications. So many manufacturers in this area, not just from Intel or AMD, they have some big names in this industry, something like Microchip, National, ST, Zilog, and many other companies. Nowadays, one of the major players in this arena is Arduino. I believe a lot of you guys have heard about Arduino. It's cheap and it's easy to implement, and it's kind of like not difficult to learn. So that is something we're going to adopt in this class, in this term. So it's just like introduce you guys to know how to use a microcontroller, and once you learn how to use the basics of Arduino, you should be able to expand your capability to other kind of microcontroller units. And most of the manufacturers provide programming tools for their devices, and many of them nowadays are still using C or C++, and that is the language we're going to adopt in this class. So in the first 1 or 2 modules, I will ask you guys to learn a little bit about C programming, and once you know how to do C programming, we're going to use this tool to program Arduino. Some of you guys might ask, so why C language? Well, for most microprocessor unit or microcontroller unit, we need to have something readable to human being. If you want to have very efficient coding applications, C, C++, Python might not be the best way to do the programming. We use assembly language. However, well, assembly language got a benefit that is super fast. So compared to all kinds of languages, assembly language designed for specific processor is going to be the most efficient language used for that specific processor. However, not everybody want to use assembly language. The biggest problem of assembly language is the learning curve is too sharp and it's very difficult to maintain. Once some engineer develop his own applications using assembly language, it is almost impossible for other people to maintain his code because assembly language, though it's simple and is efficient, but it is extremely difficult to understand what's going on for a specific function. So though it's popular in 1980s and 1990s because of its efficient coding and fast response for the program, but nowadays we normally do not use that. We are using C programming. But if you happen to use assembly language, you need to have two processes to make your system to be executable. One is you need to have an assembler to compile everything into binary code, and then we need to link the binary code into an executable file. So we have the program can be run by the microprocessor. Once those procedures has been completed, we start to download the code into the microprocessor in the flash memory or the ROM included in the microprocessor unit. Nowadays, we are using C language. So C language is kind of a very dominant language since 1980s, and it's been widely used in Unix or Windows environment, including Mac OS, because Mac OS is actually one kind of Unix. And C language is a very fundamental one because it's actually the origin of many different kind of popular languages like C++, Java, Perl, Python, and Ruby. And we can find numerous of tools that available for C language. Actually, one of the coding tool we're going to use this in this class is going to be free, and that is available. That is something we're going to talk about later in this presentation. And C is also portable because as we talked about earlier, it is very popular in Unix and Windows, which means if you develop your code under Windows, you should be able to use the code under Unix and recompile it and it still be executable under that kind of environment. So it's kind of portable, but there are some other things some other small details you might pay attention to. But in most of the cases, if you know how to program using C, you shouldn't have any trouble to understand other kind of programming languages and how to program under different kind of operating systems. So that is one of the reasons we want to learn C language. One other thing is C is not considered to be a super high level programming language. It's kind of like a little bit low but still readable by programmers. So that means or implies that if we are using C language, we have some certain capability to access a very low level or machine level of our microprocessor or microcontroller or our operating system. We can still use C to access those kind of hardware level input-output functions. So there are many benefits that learning C language. So that's the reason we are going to talk about C language in this course. However, I'm not expecting everybody to be a programmer as your career. But the bottom line is you need to know how to use this tool to do the basic things in your microprocessor unit you're going to use for this class. The required software and the hardware. Let's talk about the software part. If you want to do C and C++ programming in Windows, then there are two free things that you can download. One is CodeBlocks, which is the one we're going to use in this class, and the other one is Microsoft Visual C++. I would say this is community version. UNITY. If you still want to use a professional or enterprise, you still need to pay for it. But if you are using community version, it should be free. And CodeBlocks is also free. The reason I would like to use CodeBlock is the size of this specific freeware is smaller than Microsoft Visual C++ package. It only requires you to download 66 megabytes for the most recent, I think the most recent one at this moment when I'm taking this video is 1712. It means that it's 2017 December. But Microsoft Visual C++ though is very powerful tool. It includes too many things and make it the size is kind of huge. So for this course, you don't need to install Visual C++, but just use CodeBlocks will be good enough. After the first three modules, we're going to talk about Arduino programming. So there are two ways that you can do the practice of Arduino programming. One way is you purchase a physical one. You can purchase those kind of things in various websites. You can buy that in major websites online, or you can use a free website, which is tinkercad.com. This one can virtually emulate the Arduino board with not every but a lot of sensors and actuators. For instance, they got servo motors, they got ultrasonic sensors, so they got a bunch of LEDs. So if you can set up an account in tinkercad.com, that'll be great, because a lot of program you can complete the assignment using tinkercad.com. So the plan for this semester, the first stage is we need to understand the syntax and the structure of C++ programming. And the second stage is that we're going to learn basic programming skills of Arduino board. We're going to talk about the different sensors, and we're going to talk about how to do the programming, and we're going to talk about how to communicate between Arduino and the desktop we're going to use for your application. And after that, we're going to talk about advanced topic, which is something you need to have in your project in the end of semester. So it's going to be some kind of integrated engineering application that we're going to talk about in this class. The advantage of using C and C++, though we talked about that earlier, those are the things that we might wanna know again. One is that C and C++ is actually very powerful, and when we can, it's easy for us to integrate everything all together, and we can have multiple people to develop their own code and have a major programmer to integrate the coding from various programmers, and that is a very powerful one. With the tools nowadays, we can have programmers located at in different countries, and the programming tool can still integrate everything all together based on the timeline and the assignments of individual ones. So when we start to compile, it will take consideration of all the modifications from all over the world and compile the program into the useful one, with or without the modification in different timing. And also the C program, C and C++ program is very portable. It can be ported from Windows into Mac OS or Linux, and vice versa, because the structure is similar. So we can have everything developed under one operating system and still be usable in other kind of operating systems. And it can be modular, which means if somebody develop their own tool for specific sensors, he can just upload those kind of things into a library, and the other people or the other programmers can actually download those libraries and include in their program and have everything up and running, because everything is just modules. And also, one of the major reasons we still learn C and C++, even though Python and other programming languages are very popular nowadays, is because a lot of professional programmers are still using C and C++ in their applications, and you can find tons of resources online free, and we can actually use those kind of things to help us to shorten the programming time before we complete the whole application. So what are the environment we're going to have? So if we want to find the compiler for C language, there are two things. That there are a few open freeware that you can use. One is the most famous one, which is GNU GCC, and also you can use OpenWacom and Bolin. Now they changed the company's name, but Bolin C++ 5.5 is still free. If you want to, those are the compilers. So before we compile everything, we need to have a tool to help us to debug and check whether our syntax is correct or not, or when the compiler is actually give us some error message. How are we going to check our error message in a integrated environment? So there are many things we can do. One is using code blocks. That is one of the most popular freeware you can find in the internet. And the other one is Colite, and or you want to use MonoDevelop is also good. I think for Windows you can use Visual Studio. Of course, now it's not called Express, it's now called Community. It's actually professional version, but nowadays it's free for everybody. So as long as you are not develop your code for benefit, you can always download that from Microsoft. So there is one thing you need to know when we are develop our program. Just like assembly language, we need to have an assembler to assemble everything into binary file, and we need to use a linker to put those kind of binary file into an executable file. In C programming language, is similar, but now for C language, we do not call it assembler, we call it compiler. So you need to compile everything into .obj file if this is under Windows. And once you have those kind of things, you need to have a linker. This is actually binary file, so you still need to link the binary file into the executable file. So every procedure is similar to assembly language, but those are the things you need to pay attention to. You are not just compile everything directly into the executable file. You actually compile that into object file, and you link object file into executable file. That is a process you need to know. If you happen to use a command line compiler, you need to have two procedure to make everything executable in your system. And the basic structure of a C programming is similar for every kind of platform. So you need to have include. This is going to include the library we want to use, because we might want to use, if you just do the programming, there are many things C program doesn't know. For instance, a C program know how to do plus, minus, multiply, and divide, but it doesn't. This is something no, but something they do not know. is sine, cosine, log, those kind of things. So it doesn't mean we need to do those calculations all by ourselves. We can just include a library that have those kind of math function has been developed by many other programmers. So we would need to have some kind of header file because the actual library has been included or installed in your system. But before we can use those libraries, we need to include the header files to include those kind of things. So if you want to use sine, cosine, normally we would need to include math.h. So the stdio over here is standard input output header file. So this is a must. Math is something, if we are dealing with engineering applications, normally we need to include math header file as well. Then after that, there is one very basic thing you need to know, because when you are dealing with C programming, it will start to run the function which is main, or you can say we want to run the main function of the C programming. So it will run from the first line to the last line, then repeat everything from the beginning like a loop. So that is how a C program is working. So in short, when you are dealing with C programming under Windows, Mac OS, or other operating system, you will need to have a structure like you would have the include the header file required, and after that you're going to have a main function to run everything in this specific function. You might say, okay, I have some specific function that deal with the controller or deal with the sensor. What am I going to do? Do we need to code everything in the main function and make it extremely large? No, we don't. We're going to use other functions to deal with those kind of hardware functions, but that is going to be in the next module. So in this term, I would like to use the platform to be code blocks. So if you got a chance, please download a copy of code blocks. Nowadays, the most recent one is 17.12. If you are watching this video past 2018 December, you might have 18.12 or later versions, but it doesn't matter because the modification is not going to be too huge. The basic installation procedures remains the same. The next few slides are going to talk about how to install everything. So I'll put a YouTube video, another YouTube video over here, so you can refer to that and set up the environment and start your first program. But essentially, this software is free. You can download it from the website. I think it's codeblocks.org. Yes, it's over here. So you can download it from this website, and it's not actually too large. But be sure you download the one I listed over here, because it has also have the compiler, the new compiler included. You don't need to spend your time to find the compiler somewhere else. You can just use the built-in ones. But if you fail to do that, you might need to find out what is the compilers that you're going to install in the system. So there are many other compilers you can use, like the Boolean C++ 5.5. That is good, but if you just download this one, it will save you a whole lot of troubles. So as I said, the next few slides are talking about how to install code blocks into your system. So just follow the structure, then you should be able to start your first program, install everything and start your first program. The first one is just like what everybody uses, is hello world. So if you follow the procedures over here in your notes, you should be able to have your code up and running in no time. So that would be the introduction for this class. If you have any question, just shoot me an email, or your instructor an email. So we are happy to answer all your questions. Thank you.